Hello guys, welcome to C programming from scratch to advanced. Hello guys, welcome to C programming from scratch to advanced, brought to you by Six Phrase MySlate. And I'm Sachin, a technical trainer here in Six Phrase MySlate. And in this lecture what we will be seeing is that this extensive course. Using this course we can start from a very basic point and we will be entering into advanced concept, and this C programming course will help you in learning data structure, to get into data structure and into algorithms in a very better position. Okay, so this is a very extensive course, specially structured for people who is beginning to learn any programming language. Okay, any beginner, for any beginner this course is going to be really amazing one. Okay, so in this particular session, in this lecture, we'll be seeing how a computer works, and next we'll see how about something about number system. We'll see what is a program, and we'll see the difference between the low level and high level languages, and we will see the difference between a compiler and an interpreter, and also we will see what is a operating system. And now we'll just start this session by starting with how your computer works. Okay, so in this slide, I think it is clearly visible that you are shown with a block diagram, and this block diagram is showing the part of CPU as well as the hard disk here. And if you see here that you have something, you have right. So here there is a block diagram available, and this block diagram shows the inner part of the CPU as well as the connection between the CPU and the hard disk, the connection between the input and the CPU, and the output and CPU. And here if you see, there are several components like ALU, CU, main memory, input buffer, output buffer, hard disk drive. I'll be showing you, I'll be explaining you about each and every component, how it is our usage of, what is the work of each and every component. And first of all, let me take ALU. Okay, arithmetic and logic unit, arithmetic and logic unit. So in the arithmetic and logic unit of it, see, it does all the basic operation. For example, what are the basic operation that ALU does is that it does addition, it does subtraction, it does multiplication, it does division, and it also does mod operation also. About these operations we will be seeing in a separate video, but here let me just tell you that ALU is going to do this basic operation called the addition, subtraction, multiplication, division, and mod, as also like for example greater than, less than, and equal to, for example, and logical and as well as the bitwise and. Both are different usages there. Logical and bitwise and, same like logical OR and bitwise OR, and logical NOT operator will be there. And these are the very basic kind of operation that the arithmetic and logic unit will perform. So here in the block diagram, very first component is ALU, and this ALU will do the basic operation like addition, subtraction, multiplication, division, mod, greater than, less than, equal to. Logical and bitwise, I mean like logical and bitwise and, logical or bitwise or, and logical not. Like this, several basic operation can be performed by using the ALU component. And the next component is CU, control unit. What is the usage of control unit? You have several other resources like input system, output system, hard disk, main memory, ALU. All these are called as the resources of the computer system, and all these resources of the computer systems are controlled by this control unit. All the resources, input, output, main memory, ALU, hard disk, all these resources are controlled by this control unit. And now next comes the main memory. What is a main memory? Main memory is a RAM memory, RAM, random access memory. What is the need for random access memory? What is the need for this main memory? What is the need for RAM? Actually, if you see here, this main memory RAM is a very small memory and a very speed memory. Why it is introduced is that here is a hard disk, which is a very vast memory. For example, if you see your own system hard disk, it is like 400 GB, it is like 500 GB, 1 TB, 2 TB. But if you see your system's RAM, if you go and check your system's RAM, for example, let me show you the RAM of my system. If you just go to your PC and right click on properties, it will show you what is the RAM installed, 8 GB. It's a very limited storage. Your hard disk is like 1 TB. Okay, if you see my hard disk, it is going to be like 1 TB here, approximately 1 TB. And if you see my RAM, my RAM is just 8 GB. So why this RAM is introduced is hard disk is a slow memory. If I want to access any data inside my hard disk, then the accessor is very slow. Since the accessor is very slow, we introduce a very temporary memory called as RAM, which is a very fast memory. And so what we did is that all the programs that is in closed state will be there stored in hard disk. All the program that is in closed state will be there in the hard disk, and whenever you open a program, that program files will be copied here to the RAM, to the main memory, and then it will be executed here in the main memory only. For example, let me show you an example of it. For example, we have several software here, program files. We will see what is a program file later, but I'm using the terminology called program file. For example, there is something called as Firefox, which is a program file. Okay, so when I click on this program, now this program file is in closed state. You can see here in the taskbar also, no program file is open. Okay, no Firefox is open. Now I'm going to open the Firefox. So now the Firefox is in closed state, which is stored in the hard disk. Where is the hard disk? For example, if you see here in this, just I'll enter into the hard disk folder. In the hard disk folder, I have program files. In this program files, I have something called as Mozilla Firefox. Inside a Mozilla Firefox, if I see that I am having a Firefox, a file called Firefox. If you just click on the properties of it, it's showing that it is application.exe. So whichever programs or whichever files are .exe with .exe extension, those files are called as program files. I will tell you later why .exe files are called as program files, but generally .exe files are called as program files. So now you can see this program file is now in the, where it is in the hard disk. So when you click on this program file, now it is in closed state, so it is stored in hard disk. Now when you click on it, it will open. What is open? All these files which is in this folder are copied to the RAM, and once all the data is copied to the RAM, automatically what happens? Automatically the application is opened. The program file is in open state. If you can see here, you can see here that your Firefox is opened. Yes, so now when it is in closed state, it is in the hard disk. So you can see here, when a particular application is in closed state, it is in the hard disk, and when you try to open it, all the files that is related to the program file will be copied, will be transferred, will be brought here to the main memory, and it will be executed in the main memory. Now this entire window is now open because it is all the application codes are now in the RAM, and your program is in the execution state, because once your program files are copied to the main memory, your CPU will automatically execute it. Once you execute it, this program is now in open state. Okay, so from this what you understand is that you have a hard disk, you have a RAM. Both are different memory. Main memory is called as RAM. Hard disk is a slow memory, but it is large in size. When main memory RAM is a fast memory, but it is very limited in size. So when a program file is in closed state, it is stored in hard disk. When it is open, then these program files are transferred. It's transferred to main memory, and it is executed inside the main memory, where it is executed in the RAM. So whenever a program is in open state, whenever a program is in execution state, then it is in the RAM, it is not in the hard disk. Okay, fine. So now what is the input buffer? Input buffer is this green color is the input buffer. Why this is used? For example, you take a program file, you copy the program file, you brought the program file to the main memory, to the RAM, and now this is going to be in execution. Now your program Firefox is in execution state. Your program might require certain input. What is the input for your Firefox? For example, you can write a domain, google.com as a domain. You can enter google.com. When google.com is entered, what happens? This is the input that you give, and a certain output is displayed here. Am I right or wrong? So now what will happen is that whatever input is given through the input device, that input will be sent not directly to the application, it will be sent to the input buffer. This input buffer will be storing that input, and this application will be reading the input from this input buffer. Okay. So when the program file is brought to the main memory, to the RAM, once it is in execution state, it might require certain input, as I showed you. So those input are not directly sent from the input device to the application. This input device will send the input to this input buffer, and this input buffer will storing those inputs temporarily, and our program which is in execution will receive the input through this buffer, not from the device directly. Similarly, whatever output you need to display, those output will be sent to the output buffer, and your output buffer will be storing it temporarily, and later your output device will receive the data from output buffer and it will be displaying it. Like for example, here it displayed this google.com page here in the web browser, right? This is one kind of displaying the output. Okay, fine. So now if you see here in the diagram, we know now what is the purpose of ALU, what is the purpose of CU, what is the usage of input, output and buffer also, and what is the usage of RAM, main memory, what is the usage of hard disk. Okay, fine. Now with this thing, what I need to tell you is that there are two kinds of file. I told you directly program files, but exactly when you see, there are two kinds of files available. There are two kinds of files. What are the files? One is program files. One is program files. What is the other thing? The other thing is, one is program file, the other one is data file. The other one is the data file. So what is the difference between a program file and a data file? For example, let me open a notepad. Okay, let me show you a notepad. So in this notepad, if you see, this notepad is actually a .exe file. So whenever something is .exe, I told you it is a program file. So notepad is a .exe file, and for example, what I do is that I type something inside. I type some data inside this, and I type some data inside it, and I'm going to save it. So while I'm saving, what is happening is that, for example, test.txt, I'm just saving a file called test.txt. Okay, now just let me go to the place where I saved it actually. So here I saved something called test.txt, right? This is saved here in test.txt. So if I open it, this file is opened. For example, this is a different file, but let us just tell this is a file, some file, that text file that we have saved. So this text file is a data file which is created by using the program file called notepad. So notepad is a program file, and the file that I create, a .txt file that I create using this program file, is called as a data file. So notepad.exe, okay, notepad.exe is a program file. Okay, notepad.exe is a program file, and test.txt is a data file. This is what the difference between a program file and data file. Okay, so which programs can be executed, which files can be executed? A program file only can be executed. A program file can be only directly sent for execution. A data file cannot be sent for execution. That we should remember always. Okay, fine. So now the next thing that what I will show you is that, let me go back again to the diagram. So I think you have a complete understanding about how the computer works. You know about what is the usage of ALU, what is the usage of control unit, main memory, what is main memory, why we introduce main memory, what is hard disk, what is files. We have two different files, program files and data file. We know the difference between both is, and if some file has to be taken from here to here, then it has to be definitely a .exe file, program file. Then program file only can be brought from hard disk to the main memory. And if I want to take data, if I want to take a data file from hard disk to main memory, then it can be brought by using through, it can be brought through a system file, using a program file, where notepad is a program file and whatever written inside this is a data file. A data file, if it has to be brought to the main memory, then it can be brought through the program file called notepad only. It cannot independently come to the main memory. Okay, fine. So next one is input output buffer. You know why we require input buffer and why we require output buffer. They are temporary input output storing places. Okay, right. Next we will enter into something here. So if you see here, the entire computer system is an electronic device. So electronic device means, electronic device, everybody knows that electronic devices are controlled by using only voltages. For example, when you take a bulb can glow or it can stop glowing. If it glows means it is in on state. If it is not glowing, if it is stopping, then it is in off state. So either high voltage, if it is glowing means you are giving high voltage. If it is stopping, then it is having a low voltage. So either high voltage or low voltage. Using high voltage and low voltage only, every electronic device is working. So computer is also one of the electronic device. So it is also going to work on this voltage principle, either high voltage or low voltage, either on or off, either 1 or 0, which means a binary language. So computer, we say that computer knows only 1 and 0. Why? Because it is an electronic device and it uses a voltage principle. That is the one reason why computer understand only binary system, not any other languages. But when we come to human side, human understand the decimal number system better. What is a decimal number system? The usual number system that we are using. Decimal number system means 10 symbols are allowed. What is a decimal number system? A decimal number system means 10 symbols are allowed. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 symbols available. Okay, so when you create a number using any combination of this decimal, combination means you can take 1 and you can combine it with 0, it makes 10. You can take 1, combine it with the same 1 again. You can take 1, combine it with 2. But only the symbols allowed are 0 to 9. You can take any of these symbols and you can make any combination. Okay, the length can be anything. So that is what the decimal number system. We will see deep about number system, decimal number system later. But now just using these 10 symbols, if you're forming a number, then it is called as a decimal number system. So human understand those decimal number system only. But machine, we clearly said that it understand only either low voltage or high voltage. It means 0 or 1 only. So human understand decimal number system, machine understand binary number system. This difference we should understand. Next, so since I showed you the difference between the human understanding language as well as a machine understanding language, number system becomes a very major role, plays an important role in this. So we are seeing about number system. How many number system available? 4 kind of number system. Binary, already we saw that only 2 symbols allowed, 0 and 1. Coming to octal, 8 symbols from 0 to 7 will be available. Coming to decimal, 10 symbols from 0 to 9 will be available. Coming to hexadecimal, totally 16 symbols will be available from 0 to F, 0, 1, 2, 3, 4 and up to 9, and then 10 is represented by character called A, then B, C, D, E and F. and we say that base of binary is 2, base of octal is 8, base of decimal is 10, base of hexadecimal is 16. Why we call base? What is base? Base means number of symbols allowed. How many number of symbols allowed in binary? Only 2. That is why base is 2. Octal, totally 8 symbols are allowed, so base is 8. In decimal, totally 10 symbols are allowed, so decimal is having a base 10. Similarly for hexadecimal also. So we will not be seeing about the octal system and the hexadecimal system now, but we will see about binary and decimal, because we have already seen that human understandable code is decimal code and machine understandable code is binary code. So we will see the relationship between the binary and the decimal system. So this is a general table where I have shown the corresponding decimal, binary, octal, hexadecimal representation of few numbers. Okay, so this you can observe later. We will just get into binary as well as decimal, and we will see the connections between the decimal and as well as the binary language. See, here I have taken a number called 25, and in the bracket I am just giving 10. Why? What is the reason? Because 25 is possible in also octal as well as hexadecimal, because octal is also allowing 2 and 5, hexadecimal is also allowing 2 and 5. So this can be either of decimal or octal or hexadecimal. So in order to mention that this is of decimal, I'm mentioning the base 10. So 25 of base 10 has to be converted to base 2. How? I'm going to take this 25, the decimal number called 25, and I'll just keep on dividing it by 2. Why I'm keep on dividing it by 2? Because I want to have to convert it to the base called 2. If I want to convert it to the base called 2, I have to keep on dividing it by 2. So 25 is divided by 2. So this 25 is the divide, and 2 is the divisor, and 1 is the remainder. So just mark all these things. So dividend, I'm dividing it by 2, so I get the quotient called 12. Again, change this quotient into a dividend, again divide it by 2. You get a new quotient 6. Divide it again by 2. You get a quotient 3. So when you're dividing 25 by 2, you get the quotient 12, but you get the remainder 1. Mark it here. Then when you divide 12 by 2, you get the quotient 6, and there is no remainder, so remainder is 0. Divide your 6 by 2, you get the quotient 3, and no remainder, so remainder is 0. And next you divide 3 by 2, you get the quotient 1, and remainder is 1. So once your quotient becomes 1, stop the process. Start taking it from the reverse. Take this 1 as a first bit. The next is this 1 bit, 1, 0, 0, 1. So the corresponding binary representation of 25 is 1, 1, 0, 0, 1. So 1, 1, 0, 0, 1 of base 2. So this is how you convert a given decimal number to a binary number. Now I will show you the vice versa conversion from binary to decimal. If you want to convert the binary number to decimal, binary 11001 of base 2 to 25 at decimal of base 10, then what you need to do is that take each and every bit separately, 11001, and corresponding to every bit you write the base. Since this is of base 2, I am raising 2, the power place 0, so 2 base 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So now after writing these powers, now what you do is multiply the bit and the powers. So 1 into 2 power 4, add, plus 1 into 2 power 3, plus 0 into 2 power 2, plus 0 into 2 power 1, plus 1 into 2 power 0. That will give you the decimal answer. So 1 into 2 power 4 means 2 power 4 is 16. So 16 plus 1 into 2 power 3 is 18. 8. So 16 plus 8 is 24. Then 24 plus 0, 24, 24 plus again 0, 24, 24 plus 1 is 25. Why this is 0? Because anything multiplied by 0 will be 0. Anything multiplied by 0 will be 0. Here, anything power 0 will be 1. So 1 multiplied by 1 is 1. So 16, 8, 0, 0, 1. Adding all these things together, we get 25. This is how you convert a given binary number to a decimal number. Okay, so I have given you the method of how to convert a decimal to binary and how to vice versa convert binary to decimal. And these operations are done automatically in the background by the CPU. but even though we learn it to understand the working of CPU very better. Okay, fine. So now after seeing these conversions from binary to decimal and decimal to binary, now we will see what is a program, because in the first slide itself I told you something that only program files can be brought here to the main memory, but I did not tell you what is a program file. I told you the difference between program file and data file. A program file is .exe file and a data file is like .txt file, but still now we have not seen the clear explanation of what is a program file. So now we will see what is a program file. For example, see, why we require program is that to perform a calculation, to perform computational calculations. I think computational calculations can be performed by the calculator itself, you know, but why we require computer programs, we will see now. For example, let me open a calculator. For example, in the calculator, let me first of all take adding two numbers. What two numbers? I'm going to add 5 and 6. To add 5 and 6, what you will do, you will go to the calculator and first of all you will press 5 followed by the plus sign, because you need to add. So I'm entering the plus operator, then 6, then equal to. So this will show you the sum of two numbers. So it means that it is very clearly evident that this operation, adding, is an operation, and this operation, your calculator knows how to do this operation. Your calculator knows how to do the add operation. So you are adding two numbers. Calculator know how to add two numbers. So when you give the input, it is adding and it is displaying me the output. Now let me give you one more task. You need to find the average of numbers. For example, I will take few numbers called 10, 15, 8, 6, 9. Okay, it is 10, 15, 8, 6, 9, 5, 12, 13, 11, 16. For example, let me take these numbers. How many numbers we have taken so far? 3, 6, 9, 10 numbers. So if I want to find the average of these numbers, what we need to do? Go to a calculator, take a calculator, and this calculator, what you need to do is enter the numbers one by one. First of all, find the sum of the numbers. So first of all, I will enter 10, then followed by plus, then I will enter 15, followed by add, then I will add 8, then again plus, then 6, add 9, add 5, add 12, 13, 11, and 16. What's the total that you get? You get 105. If you want to find the average of these numbers, what you need to do, how many numbers you added? You added 10 numbers. So you have to divide this total sum by 10. You have to add these two numbers, add the total, you have to divide the total number by the number of elements you have added. So when you divide, you get 10.5. Can you understand one thing? When you perform add operation, this plus operator directly knows what to do, and our add operation calculator itself knows what to do, and it is doing the operation. But coming to average, the calculator does not know how to find average. We are giving instruction, adding all the other numbers, then finally dividing it all the numbers by 10. So add is a single operation, but average is not a single operation. Average is adding several numbers, as well as division is also taking place. So add is a single operation, but whereas average is not a single operation. It is a multiple operation. When multiple operation is taking place, then I can call that as a procedure. So average is a procedure. It is not a single operation. but add is a single operation. When it is single operation, then calculator will comfortably do it. But when it is coming to the average, when it is coming to procedure, then it does not know procedure. Then the human who is using the calculator knows the procedure, and we are following the procedure to get the average, but calculator is not giving the average by default, like adding two numbers. So when a procedure need to be done, then calculator cannot be used. Then I need to come to a computer system. So in the computer system, what you're doing is that you are writing lines of instruction. You're writing lines of instruction, and those lines of instruction are saved as a file. What this file will do, this file is having a collection of instructions, and these instructions together perform a particular procedure. When a particular file is written for executing, is written for doing a particular procedure, then that file is called as a program file. So what you do, you write a collection of instruction. Why you write a collection of instruction? To perform a procedure, and this collection of instruction is saved as a file, and this file is called as a program file. So a program file can be also called as a program file is a collection of related instruction that together perform a certain procedure. Okay, so whenever you want to perform a procedure, so write instruction, save those instructions as a separate file, and that file becomes a program file. Hope you understand what is a program actually, right? So now let me show you some other thing. Now the same number I have taken, these are the numbers which I have taken to find the average. And now if you see, this is data, and I told you I have to find average. If you want to find average, you will write certain instruction to find average. So data is there and certain instructions are there. That instruction will be performed upon the data. You have certain instruction. For example, what are the instruction that will find average? Those instruction will be carried out. That will be carried out upon the data. Now if you see what is a form of data and what is a form of instruction, the data will be English. For example, these numbers are English numbers, called as generally termed as English numbers. So let me take that it is in the language called English, and also the instructions also there in English only. So when the data is in English, instruction is in English, these instruction has to be executed by the computer. These instructions has to be executed by the computer. But computer knows only binary language. We already saw computer only knows machine language. Since computer knows only machine language, it cannot directly take your data and instruction which is in the English language. So generally this language is called as natural language. The human understandable language is called as natural language, and the CPU understanding language, computer understanding language, is called as machine language. Since this is not a machine language, this is a natural language, this cannot directly be taken by the CPU and executed. Now what to do? We have two options. Either CPU have to learn the language of humans, or human have to learn the language of machine. Both are a difficult task. Since both are a difficult task, we introduced a new language called programming language, which can be understood by the computer also, as well as it can be understood by the human also. Okay, so what is this So we introduced something called as programming language, which can be easily understood by the human as well as by the computer, a common language for both the human as well as computer. So what happens here? Our natural language code is, we are converting this natural language into a programming language. So we write some instruction in the programming language. So our natural language is converted to programming language. We are converting it. Nobody externally is converting. We are converting it. Okay. So we are writing instruction in a particular programming language. We have several programming languages that we will see later, but we choose some programming language and we write all the instruction and we provide the data in the programming language, and those programming language instruction will be later converted to the machine code, and then only it will be sent for execution. It is not directly fed inside the CPU. It is converted to a machine code and then only it is sent for execution. Who is doing this conversion? We can generally term it as translation. Who is translating programming language into machine language? Compiler or interpreter. Here comes a new two terminologies called as compiler and interpreter. So we will see about the compiler and interpreter later. But any programming language have to be converted to machine code and it has to be translated, and this translation will be carried out by either a compiler or an interpreter. Okay, so we will see about compiler and interpreter later, but now I'll stop here and I'll tell you that we have several languages like programming languages, natural languages, machine languages. We have several languages. I need to classify these languages into two categories. One language is called as low level language. One language is low level language. What is low level language? All the languages which are understood by the machine. All the languages that are understood by the machine are called as low level languages. For example, there are two kind of languages that machine understand. One is machine language, directly ones, zeros and ones, machine language. What is the next thing? The next thing is, one is machine language, and what is the next thing is? Next thing is assembly language. I think hope everybody know what is assembly language. What is the assembly language? Assembly language is a language that is directly connected to your hardware, and using assembly language only program language was created. See, assembly language is also not directly understood by the computer. It also has to be converted to a machine language, then only it will be the computer will understood. But assembly language is a raw kind of language using which we have developed many programming language. Now, so low level language means machine understanding languages, machine language and assembly language. Coming to the next category, it is high level language. What is high level language? High level languages are the programming languages which is understood by the humans. So for example, we can take C, then let me take for example, let me take C++, CPP, C++, and let me take Java for example, and let me take Python, and let me take C#, and for example let me take VB, and we will take VC++. So for example, so low level languages are the languages which is understood by the machine, and high level languages are programming languages which are understood by human, as well as it is understood directly by the humans. So these high level languages can be categorized. They can be categorized into three. What are they? One is compiler based high level language. So compiler based. What is the next one? Next one is interpreter based. What is the next classification? Next classification is a hybrid high level language. So now we will see what is the difference between compiler based, interpreter based and hybrid based high level languages. But before that, we will first of all come to a conclusion. What is the work of compiler? What is the work of interpreter? And we will see that. Then we will come to the difference between compiler based languages, interpreter based languages and hybrid based languages. And coming to compiler based language, C is a one big example. C and C++ are one big example for a compiler based language. For example, to make you understand, let me show you some C language code, and you need not to understand the code what is written here, but let me show you some C language code and what a compiler will do. So for example, if you see this, what is this actually? This is a data file. this is a data file. Why I call this is a data file? Because Visual Studio is like Visual Studio.exe. It is a program file, and whatever you create inside this program file .c, I told you .exe is only program file, all the other files are data file. So this is not .exe, so definitely this is a data file. A data file cannot be directly taken to the CPU and cannot be directly executed. So for that, what you need to do, first of all, you have to convert this natural language. You have to convert this data file into a machine language. How will you convert it to a machine language? You have to do translation. How will you translate that? I told you, using compiler. So what you do is that for this corresponding line, there will be a corresponding translating line for the machine code. So what you do is that you check this line whether if there's any error or not. If there is no error, convert it into a machine code. So first of all, you check for errors. If error is not there, what you will do, you will convert it to a, if there is no error, then you convert it into a machine code. So this line. So for every line this is performed. This checking error and converting to a machine code is happening. So check error, and I just move to every line. I do this process for every line. So for every line up to last line. So when I do it up to the last line, when it is finished, if there is no error in between, if there is no error in any of these lines, and what finally will happen is that finally executable file will be created. It means that a .exe file will be created. What that exe file will be having? That exe file will be having all the machine code. Each and every line is converted to a particular machine code, right? That machine code cluster of all the line machine code, all the machine code will be stored in that particular .exe. For example, I will show you. Just I will execute this program and I will show you. For example, I will be executing this GCC, and what I have to do, I'm going to do a translation, right? Translation from a file, from a data file to a program file. So you need to mention what is the name of the program file you are going to generate. I'm going to generate it like hello. Hello is the name of the output file, which I say. What is the output file? It is a program file. So name of the program file is hello, followed by what is a file that you need to translate. Binary search.c is a file, data file I need to translate. So when I give this line, what happens is all these lines are executed. So each and every line is converted to a machine code, and since there is no error, is shown. So what will happen? The entire lines, all these lines are converted to machine code, and this machine code is clusterly stored in, for example, I'll show you in the desktop in a particular folder. I'm having that file. Okay, I'll go to data structures, arrays, and I have, you see binary search.c is here, source file. You can see source file and type application. So this is hello what we created. So if I go and see the properties, the type of file, it is .exe file. So what happens actually, can you able to understand? You have a source code, you have a natural language, you have a data file, and this data file cannot be directly executed because your machine does not understand this natural language. So you have to translate it. How you have to going to translate? Using the compiler. What your compiler do? It checks for the error of every line, and if there is no error, it is converting into a machine code, and that machine code is clusterly stored as a .exe file. Now .exe file means it is a executable file. It is a program file. Program file means it is having only zeros and ones. So now the program files are understandable by the computer, and directly you can send this .exe file to the compiler, so to the CPU. So in the first slide itself, I have shown you. Now your program file is created in the hard disk, which is hello.exe here in the folder. If you see hello.exe, and this program file can be sent to your main memory directly, and hereafter it can be executed. Fine. So now let me come back again here. So if you see here, C is one of the compiler based language I told you. So what is a compiler? What is the usage of the compiler that we have seen so far? What does compiler does? A compiler will check for error. First of all, it will check for error. If there is no error, okay, if there is no error, then what will happen? Then each and every line, okay, each and every line will be converted into machine code. This is what your compiler will do. Okay, if there is no error, okay, fine. If there is error, what will happen? That also we need to know, right? If there is error, if there occurs error, what has to happen? For example, I'll show you here. Suppose if binary.c, if there is any error here, for example, the error might be here. What is the error? I can just take the semicolon. If I take the semicolon, it is like error. We will see why that semicolon is given. That all we'll see later. But if the semicolon is not provided, it is considered as an error. When error is made, what will happen? What compiler will do is that it will check up to this line. No error is there. But since error is found at this line, no executable file can be created. Why no executable file can be created? Because executable file is a collection of machine code of the entire source code. For the entire source code only, executable file have to be created. Since there is error in this line, you cannot proceed with the executable file because you don't have the mission code. You have the mission code of every lines. You have the mission code of the partial lines only. So when error is occurring either in the first line or even in the last line, what will happen? Your compiler will not create any file. Your compiler will not create any program file. So if error is found at any line, if there occurs any error, what will happen? Then no executable file will be created. No executable file will be created. So what we can say further? No executable file means no program file. So when there is no program file created, what cannot happen? Execution cannot happen, because this program file only we need to send it to CPU for execution. But when no program file is created, what cannot happen? Execution cannot happen. So no execution if error is happening. No execution can happen if error occurs. So I think that's very clear. Now let me show you one more thing. But even though the error is occurring here in this line, error is occurring here. For example, I'll just save this document. Again, let me just compile this after making a syntax error. I'll just again now it is showing a compilation error. Since the compilation error is done, no file will be created. But if you go and see the folder, still the last created hello.exe is still here. So what you can say is that only one time translating is enough. Translate the given file to a program file for only one time, and that executable file will remain saved forever. So you can use this translated file anytime. You no need to translate again. Only one time translating is enough. So you can say the next feature is that, what is the next feature? Next feature is that for the compiler, only translating one time is enough. Okay, translating one time is enough. Fine. Now we will come to interpreter. You know what is compiler. Now we will come to interpreter and we will see the differences. And one important language which comes under interpreter based language is Python. So Python is a interpreter based language. You need not to know what is Python, how Python is written, but we will take a simple program of, not a simple program, a program of Python. And now using this, what I need to tell you is that we will compare each and every line here. Check for error. Yes, this also will check for error. Each and every line will be checked for error. If there is no error, for example, here this line, I will be checking for error. Okay. Here, I will just check for error, and if error is not found, if error is not found, what I will do is that I will just translate it. Okay, I will just translate to a machine code, and simultaneously I will translate and simultaneously execute it. I will simultaneously execute it here itself. So it is very clearly, you can able to see the difference. I check for error for every line, and if there is no error, it is translated. Once it is translated, it is simultaneously executed there itself. So if it is executed in the time of translation itself, then no execution file is created. There is no need of any program file here. There's no need of any program file. So for the first point that you should remember is you are going to check for error, and if there is no error, if there is no error found, then each and every line will be translated. For example, it will be translated and executed simultaneously. So because of this translation and execution happening at simultaneous time, what will not happen? Executable files will not be created. Executable files will not be created. So it means that there is no program file for interpreter based languages. So if you come here, there are no program file for an interpreter based language. So now what will happen is that execution will happen, and here you cannot say that translating is going to be only one time. No, because since no program file is created here, what cannot happen? Execute every time when you want to execute, every time you have to perform a translation, because no program file, the translated code are not saved anywhere. So one time translation is not possible. So one time translation is not possible. And now, since program file is created here, the program file is sent to the program file is sent to the main memory and is executed. What is main memory? RAM. I told you, when the program is closed, then it is in hard disk. When it is open, then it comes to RAM. When it is open means when it is in execution state, it comes to RAM. So when it is a program file, then I can take it to the main memory and I can execute it. But there is no program file here in the interpreter. Since there is no program file here in the interpreter, what cannot happen? The execution is not happening in the CPU. Then where it is happening? It is taken care by the CPU, but it's not directly executed by the CPU. It is indirectly executed, but the execution is happening inside the interpreter. Here program file is created. So since program file is created, I'm sending the program file to the CPU for execution. Here no program file is created, so I cannot send any file for execution to CPU, but instead of that, what I'm doing is inside the interpreter itself I'm executing. So here execution is happening outside the compiler. Here execution is taking place inside the interpreter. So this is taken care directly by CPU. This is taken care, interpreter is taken care indirectly by CPU. So interpreter based languages are slow languages because it is not taken care by the CPU directly. So interpreter based languages are slow languages, compiler based languages are fast languages. So C++ are called as fast languages, and Python, Ruby languages are interpreter based languages, which are called as slow languages. And now here comes a game, like now it comes to hybrid. What is hybrid? Hybrid means it uses both interpreter as well as compiler. It uses both interpreter as well as compiler. Any example for it? Yes, Java is one best example for a hybrid language. So Java is one better example for a hybrid language. So Java is very powerful language because it uses the feature of both compiler as well as interpreter. Right? I think by this illustration it is very clear to know the difference between a compiler based programming languages and interpreter based programming languages, and what is the usage of compiler, what is the work of compiler? Translation. What is the work of interpreter? Translation. But these translations are happening in a very different manner in compiler and different manner in interpreter. Okay, so now we have seen how this is how compiler and interpreter is working, and now we will come to something called as operating system. Very important part. What is the operating system? What is the operating system? Operating system is also a program file. Operating system is also a program file. For example, if you come here, operating system is also a program file which is stored in the hard disk, but it is a master program file. What is a master program file? This program file, this operating system will be there in the RAM. Once you switch on your system, automatically your for example, if you have Windows, what happens? What is the common operating systems we have? The common operating systems we have is Windows, and we have Linux, and we have Mac OS X. Okay, so these are all common operating systems that people use. And these are the common operating system that people use. An operating system is a master program that manages all the resources. Okay, it is a master program that uses all the resources of the computer system, CPU, hardware resources of the CPU, to provide services. What services? It is this master program called OS will only give instruction to the CPU to execute all the other program files. For example, we are inside operating system. Inside the operating system only, if you see, inside the operating system only calculator is there. Inside the operating system only notepad. Inside the operating system only we have the browser. So all these program files are inside a master program, like called as operating system. So if I want to ask my CPU to execute a particular program file, for example, if I want to ask my CPU to execute a Firefox program file, then my operating system, which is a master program file, which need to request my CPU to execute this program file. So operating system is a master program file that manages all the other program files. So it is a manager. So operating system is a manager. Fine. So this is what you need to understand about your operating system. That's a basic thing about operating system, right? So I think what we started with the session is that we started with the agenda of knowing how a computer work. I think we know now how a computer work. What is ALU? What is control unit? What is input and what is output? What is main memory? What is RAM? What is hard disk? So you know all these things. And coming to number system, you know what is the number system available, what is called as base, you know what is binary, and you know what is decimal, and you know the conversion of binary and decimal, vice versa. And you know what is a program also. I told you an example also for what is a program. Then a difference between a low level and high level languages. Then we came to compiler versus interpreter, and finally we ended up with operating system. I think the agenda is very clear, and also it is very clearly evident that we have finished the agenda to the code. So all these things you should be very clear enough in order to learn any programming language, not only C. If you know all these things only, you know what happens while you are compiling, what happens when you are interpreting something, what happens when you execute something. Then only you will be able to understand the behavior of any programming language better. Okay, so in the next session what we will be doing is that we will be learning about something called as programming paradigms. What is programming paradigm? Means style of coding. We will see few styles of coding that is very important before we start to learn about any programming language. Okay, so we will see about programming paradigm in the next lecture, and we will continue to the first program. We will start with the basics, and we will enter into data types, and we will move forward. Okay, so we are going to do everything in a slow manner, because we need to be very clear in whatever we are going to do. Okay, so hope it is very clear, and if there is any doubt, and this video is available in the in our channel, and first of all what you do is that you just subscribe to our channel and follow the channel. We keep on creating a lot of live sessions useful for the students. And one important thing is that And one more important information is that you can go to the link called myslate.sixphrase.com, and in this link myslate.sixphrase.com, okay, yeah, in this link there is n number of courses available, like Python programming, Java, data structure, C programming, LNT test series, TCS Ninja, and we have programming languages, data structures, algorithms, as well as we also have company specific problem sets, also courses. So this is all industry oriented questions are there. So what you can do is that if you want to purchase this, let us know through the comment section and we'll help you in purchasing these courses. And anybody who want to purchase this course can just give a comment if there is any problem in purchasing it, and we'll be helping you at the back end. Okay, so all these courses are very useful, guys, and I will recommend you to purchase these courses one after the other and complete a course and then go to the next course. Okay, so when you just finish all these courses, then you will definitely be able, you'll be ready, you'll be ready to be entering into, you will be ready to crack any company specific company. So if you take these courses, and if you take the best of these courses, and then I can assure you that you can enter into any organization with ease. Can enter into any organization with ease. So thank you, guys, and this is it for the session, and we will meet in the next session. Thank you.